In this lesson, we're going to talk about the domain name system, or DNS. The DNS protocol is used to help your network clients find a website using human-readable host names instead of a numeric IP address. For example, if I told you to visit our website, I can simply say, hey, go to www.diontraining.com. And that's a lot easier for you to remember than have to remember that it's 66.123.45.237 or whether the IP address of the web server may happen to be. After all, saying out all those numbers as part of a TV commercial isn't quite as catchy or memorable as telling your consumer to visit you at www.diontraining.com or Coca-Cola.com, Microsoft, whatever. So how does the computer know how to find the web server's IP from these domain names? Well, that's the purpose of DNS. The way DNS works is when the user's computer is told to go to diontraining.com, it reaches out to a DNS server that says, hey, who is Dion Training? This DNS server will then reply back and say, oh, the IP address for Dion Training is 66 blah, 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 right? You get the picture. Then the client can get redirected to the web server using the router and their WAN connection since they now know the right IP address to the destination. This all happens in the background for your users without them even having to ask because DNS is such an embedded part of our networks and systems. Now, most of us as home users won't run our own DNS servers, but instead, we might rely on our internet service provider to do this for us. But if you are running your own website or a large corporate network, for say, you might also have to use your own DNS server in your network, and you will be responsible for setting up your own DNS records that dictates what servers are located and at what IP addresses. This allows you to run your own domain name and host resolution, which will convert those domain names into IP addresses. If you want to think of it this way, it's similar to a contact list on your phone. Nowadays, how many phone numbers do you actually have memorized? Probably not a whole lot because you pull out your cell phone, you scroll to the person's name, and you hit the name with your finger and it dials them right up for you. For instance, if I want to call my buddy Jason, I scroll to his name, I push a picture of his face on my phone in the contacts, and immediately it dials his phone number. I don't have to memorize all those 10 digits. That's just because we just do better with names. Now, one of the concepts with DNS is what we call FQDN, or fully qualified domain name. This is when a domain name is under a top-level provider. The most common top-level provider is .com. We also have others such as .mil, .edu, .org, or .net. For example, at diontraining.com, we have multiple servers. One of our servers is our web server located at www.diontraining.com. The top-level domain is .com. The domain name that we use is Dion Training. To be fully qualified, I added the www in front of it, making it www.diontraining.com. If you want to get to our web server, that's what you will type into the browser, www.diontraining.com. Then you are redirected to the web servers because DNS knows that it should resolve the IP address of the web server. Now, if you want to go to our file share, on the other hand, you would type in ftp.diontraining.com. If you want to go to our web server, you will type in mail.diontraining.com. All three are examples of fully qualified domain names, again, also known as FQDN. Essentially, they have a service, a dot, a name, a dot, and a top-level domain. And this works the same way no matter which domain you're looking at across the internet. Now, DNS is set up as a hierarchy. This occurs at 5 levels: root level, top-level domain, second-level domains, subdomains, and the host. The root level is the highest level in the DNS hierarchy tree, and the root name server answers questions in the root zone. These servers contain the global list of all top-level domains such as .com, .net, .org, .mil, and others. The second level down we have is the top-level domains. These are broken up into 2 categories: organizational hierarchy such as .com, .net, .org, and others, the geographic hierarchy such as .uk for the United Kingdom, .fr for France, .it for Italy, and other countries. The third level down is known as the second level domains. These domains sit directly below the top level domain. For example, our domain diontraining.com is a second level domain, and it sits beneath the top level domain of .com. The fourth level down is known as the subdomain. So if we wanted to create a new server underneath our second level domain of DionTraining.com, we can do that by using a subdomain. In our case, we have a lot of subdomains, including www subdomain located at www.diontraining.com, and the support subdomain located at support.diontraining.com, and numerous others. The fifth and final level domain is the host level. This is the lowest and most detailed level inside of the DNS hierarchy and refers to the specific machine. When we think of DNS, most of us tends to think about a fully qualified domain name, something like www.diontraining.com, which contains a subdomain, a second level domain, and a top level domain. Now, if we want to take it a step further, we can look at it from a URL perspective, which is a uniform resource locator. Again, take our web server as an example, www.diontraining.com. That's a fully qualified domain name, but that doesn't tell you how to access it. Do you want to access it securely or insecurely? Well, if you're going to give us your username and password, we should make sure we do this securely. We add https://www.diontraining.com, and that becomes a uniform resource locator because it has the HTTPS at the beginning. If you wanted to do it insecurely, you could add http:// to the beginning. If you wanted to connect using FTP, you'll use ftp://ftp.diontraining.com as the URL. Next, we need to talk about the different type of DNS records. Inside your DNS server, you will create different records that hold different types of information. These are known as A records, AAAA records, CNAME records, MX records, SOA records, PTR records, TXT records, SRV records, and NS records. Now, up to this point, I've talked about DNS from the perspective of hosting a publicly available DNS server that anyone in the world can access. But DNS can be used internally or externally. These days, with cloud computing, it is common to set up an internal DNS service that lets your cloud instances within the same network or private cloud access each other using internal DNS names instead of having to know each of their IP addresses. To do this, internal A records are created and internal pointer records are also created in a reverse zone. Luckily, most cloud providers will automatically create, update, and remove these internal DNS records for you. And they will do this as you create and remove different virtual machines and other instances in your private cloud. Now, external DNS is what we are most familiar with. These are the records created around the domain names we purchase from a central authority and use on the public internet. Now, each DNS record we create also has a TTL or time to live associated with it. The TTL is a setting that tells the DNS resolver how long to cache a query before requesting a new one. So if our DNS records are set with a time to live of 86,400 seconds, which is usually the default, that means when my computer resolves the DNS record, it will remember it for 24 hours before it has to ask the DNS server for that information again. This DNS resolver, also known as a DNS cache, is located on your individual host. So if you're running Windows 11, for example, your computer is making a local copy of every DNS entry it resolves as you connect to websites on the internet. This temporary database remembers the answers it received from the DNS server. So if you go to DionTraining.com, the first time your computer has to ask the DNS server for the IP address. But now that it has it, it remembers that IP address for the next 24 hours. If you visited our website 5 times today, you only had to look up the IP address once. This helps speed up the process. Now, if you try again tomorrow, your computer will first check the DNS cache to see if there's a record there. But the time to live has passed, it will invalidate that record and perform another lookup. The final thing we need to cover is the concept of a recursive lookup. You see, when your computer wants to find a given website like DionTraining.com, it first will ask the DNS server where it's located. So if you're sitting at home using a Verizon Files connection, you will ask the DNS server, who is DionTraining.com? Now, Verizon's DNS may or may not know the IP address for DionTraining.com. After all, there are millions and millions of websites out there, and if they had to resync the records every 24 hours for them, it would take a very long time. So instead, DNS uses a recursive strategy to perform the lookup. So you ask Verizon, if you don't know the answer, it will go up to the next level and ask the DNS server. If that server doesn't know the answer, it will go up another level. And this process continues until it finds a server that knows the IP address of DionTraining.com. If it reaches the root domain for DionTraining.com, then it can ask the .com root server which DNS server hosts the information for DionTraining.com, and it will get the authoritative answer. Essentially, with a recursive lookup, your DNS resolver is saying, I don't know what this domain IP address is, but I will ask my DNS server, and that server will hunt it down until it finds it. There's another method that we can use that's called an iterative lookup. With an iterative lookup, it is similar to a recursive lookup, except that the DNS server will not continue to look up the information for you and send you the result. Instead, an iterative lookup, your DNS resolver will ask the DNS server what the IP for the domain is, and if the DNS server doesn't know, it tells your resolver to ask the next DNS server and provide its IP address. So with a recursive DNS lookup, the DNS server will hunt it down and report back to your resolver. But with an iterative lookup, your DNS resolver will continually query DNS servers until it finds the one with the IP for that domain. So remember, the DNS or domain name system is a system that translates domain names into IP addresses, allowing users to access websites and other resources on the internet. It is a critical aspect of cloud computing as it enables users to easily access resources on the internet by using domain names instead of IP addresses.